Hi, this is Alana Francisco and Chinyu, and in this presentation 10, we'll be talking about an open problem in industrial engineering that could be solved using simulation. For the problem description, we'll be talking about real-time mixed integer programming. In this integer programming, this type of programming provides a solution that is within an acceptable tolerance of the optimal solution. It also is used to solve highly complex and difficult problems that normal mixed integer programming cannot compute itself, and it also provides the solution in a timely manner. This requirement distinguishes integer programming from heuristics like greedy algorithms and local search, which can often be very fast and possibly have finite worst case bounds, but does not provide tight optimality bounds on individual instances.
We found some literature on the issue of real-time mixed integer programming. The article that we found mostly talks about the problematic areas of it rather than giving some type of solution. So the title of it is Great Unsolved Problems in OR, from Real-Time Mixed Integer Programming to Improving Air Traffic and Disaster Management. Plenty of challenges await operations research. Some things that we found in the article were about like drone usage and them being implemented for delivery, and there could be some problems with using so many drones and them having to know where other drones are located so that there are no accidents or crashes that might happen. Even with birds that are in the sky, just different flying entities that may be out there. And then also, you have to look at the time of it, which is the main focus that we have here, and it having to be some type of high speed computation for these type of problems, because if the model isn't in seconds, then you're going to have something that updates all of the different variables as quickly as possible, and it has to be fast so you can have a result at those different increments of time. And then we also have the ability for it to have a lot of storage of data. It needs to memorize all of these things and use them when needed. And then also, the problem is more prevalent in applications that need to look at the time in terms of seconds, like I mentioned earlier, but there's also the usage of it in minutes and hours. These are also considered real time applications. With the minutes and hours, they do not have to be as fast computations, but they also do have problematic areas when we're looking at those time periods.
There are several ways to approach solving real-time mixed integer programming. Some of the ways we thought of were to develop faster processing systems. Some of today's computing system ability is still very limiting in their processing capacity. The other ones could be changing its setting a little bit, so when it's checking for optimal solutions, we set specified intervals to check for solution, or when it's on demand, like when you need the solution at the time, then you check for it instead of constantly solving for it. And the other one is a Monte Carlo simulation can be applied by simulating random numbers and picking values close to it that has the most optimal solution instead of testing a range of values or every value in that range.
Thank you for watching our video about real-time mixed integer programming.